Hello, and welcome back to Learning Minecraft Command Blocks. I, as always, am your host, Dr. Brian Lorgon111, and last time we had managed to use a number of command blocks as well as the scoreboard to do some interesting mathematical computations, and today we are going to learn to put those computations to use. So let's get started. Let's start off simple. Suppose I want to place a block of wool 10 blocks out in that direction. There's a number of things I could do. Obviously, I could walk over and place it on the ground, which isn't all that interesting. But based on the commands we have learned before, you probably know that we could say set block tilde 10 tilde tilde wool. And that will place a block 10 blocks away because we used relative coordinates. Tilde 10 means 10 up in the x direction, tilde means same y, and tilde means the same z as myself, and so we placed wool over there. So that is one way that we could do it with commands. But suppose, instead of just the number 10, suppose I had used some other command blocks to populate a score in the scoreboard. I could say scoreboard players set n in my objective that we created last time, 10. And so let's suppose I had a variable named n in the scoreboard whose value was 10, and I wanted to use that value to place the wool block way out there, 10 blocks away. How would I do that? Well, you can imagine that we might take something like this that we just did a moment ago, but instead of 10, say n. But that won't work. N is not a valid number. And, you know, n is in my objective. There might be other objectives, and so you could imagine like all kinds of magic syntaxes that might possibly work, but they do not work. And as it turns out, there's no way to do what I'm trying to do over here using a variable value. There's all kinds of different commands like set block and different things that take coordinates, but they all take either absolute coordinates, where you can have a constant like 10, or relative coordinates, where you start with a tilde and then have some other numeric constant like 10. And yeah, that's all the things that you can use in those commands. So that begs the question, if I want to compute how many blocks away I'm trying to place the wool, how do I do it? In Minecraft, there is no way to use computed values in coordinates of commands. However, there is a different way that we can have the same desired effect. And a clue to that is already on my bar here. There is a cow, and a cow is an entity. And it turns out that what we're going to need to do is execute commands relative to teleported entities. So we're going to have to talk about the entities a bit today and figure out how to summon them, how to address them in commands, and how to execute commands relative to those entities. And so that's going to be the majority of what we talk about today. I don't think it's easy to quickly sum up what an entity is in Minecraft, but it's easier to give a few examples. The player is an entity. That cow over there is an entity. A zombie would be an entity. An armor stand is an entity. In general, but it's not entirely the case, most entities in the game can kind of move around, and some of them kind of do interesting things. But in any case, there's a number of things that are called entities, and what we're going to need to do with them is to create or summon some of them. Then we'll need to be able to address them, that is, refer to them in commands, and then execute commands at their locations in order to accomplish different things at remote computed locations. So let's try to go through those 3 steps one by one: summoning entities, addressing entities, and then executing commands at entities. You've already just seen one way you can make a cow, which is to get a cow egg out of the creative inventory and then just place it on the ground. Here in creative mode, we'll summon a cow right at that location that you put it down. But if we wanted to do it with commands, we would use a command that I can't remember if we've seen before, but it's called summon. And you can summon any of the entities in the game. So I could say summon cow, and it will summon a cow at my location. You can also do summon with coordinates. So I could summon a cow 2 blocks over in the direction that I'm facing over here, and a cow will get summoned 2 blocks over from where I'm standing. And yeah, that's kind of the essence of the summon command. Often it is the case that rather summoning a cow, I will summon an armor stand. And so I could summon an armor stand 10 blocks above me in the Y direction. And where is it? It just fell in my head out of the sky. And yeah, armor stands, like a lot of things by default, will obey gravity. Armor stands, for reasons that I'm not going to explain this episode, are very useful for doing a lot of movement through the Minecraft world with command blocks. One of the reasons is that one of the things you can do with armor stands is give them a tag no gravity :1 when you summon them. And then, rather than falling out of the sky, the armor stand just stays exactly where it's put in the air. And so that's one reason that armor stands are good to work with. I'm going to go ahead and break this armor stand. And so we're going to be using armor stands as our main summon object. But in any case, summon is the main command that you need to learn, and it takes the name of an entity, it takes some coordinates, and then optionally some other tags associated with that entity in order to run it. Now that we know we can use the summon command to create new entities out of thin air, we need a way to be able to address or refer to a particular entity. And to show this off, I'm going to introduce the kill command. The kill command, you can just type /kill and kill yourself, but it takes an argument, and that argument is a target selector. We've kind of seen these a little bit in passing. They often will start with the @ sign. You can do things like @A for all players, @P for the nearest players, @E for all entities, but then they can also contain kind of other descriptions. So I'm going to say type equals not player, not being the exclamation point. So kill @E, type equals not player, and there's no spaces inside that entity selector, will kill an armor stand and 4 cows. Just got destroyed, as we can see in the chat. Killed armor stand, killed cow, 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 cow. And so basically, that entity selector will target all entities in the game whose type is not player. So it's not going to kill any players, but it's going to kill everything else. And I see some more entities on the ground now, some leather and some raw beef. And so if I were to run the same command again, I would end up killing those items as well, because those items that were sitting on the ground were also entities. If I drop the spawn egg on the ground like that, I could kill it as well. The same way. Item.monsterplacer apparently is its technical name. I did not know that off the top of my head. But basically, these entity selectors give us a way to refer to a particular entity or set of entities to use in a particular command. And so once again, if I were to, let's summon another armor stand and summon a cow and just show off a little bit more with entity selectors. If I want to kill the cow but not the armor stand, I could say kill @E type equals cow, and we'll kill the cow, but the armor stand will be left standing. If I want to kill the armor stand but not these item entities that are on the ground, I could say kill type equals armor stand. And if I just want to kill these item entities, I could say type equals item. And I guess in terms of learning about all of the things, if I just type /summon, I guess it just says entity name here. So you could look on the wiki to kind of like learn all of the different types of entities that there are, but there are lots. You can use tab completion. If I just type C and tab, you can see a few of the different entities whose names begin with the letter C, for example, to learn what the different entity names are. But in any case, we're going to stick to armor stands for the rest of today's episode, so we'll run with that. So far we have learned how to make an entity with a summon command, as well as how to address or refer to a particular entity or set of entities using target selectors. And now we just have to learn how to execute commands at an entity. And to execute a command at an entity, we'll end up using the execute command. I'm going to go ahead and summon another cow really quick, and then show off an example of execute. So execute takes a target selector. In this case, I'm going to say @E type equals cow in order to address this cow. Then some relative coordinates. I'm going to say tilde, which means the coordinates the cow is currently at. And then another command to execute at that cow. So I'm going to say set block tilde3 wool, which is going to place wool 3 blocks above the cow's head. And there we go. It did exactly that. And what's nice about this is I can run that same command a little bit later in time, and the cow will have run somewhere else, and I'll end up placing wool in that location or in that location, depending upon where the cow moves over time. And so this is a case where I am using the same set block command with the same fixed constant coordinates, but having things happen in different locations based on the fact that an entity is moving in Minecraft. And that's going to be the key to using computed values to put things in different places in the world. Pay your regards to the cow because he's going away. Goodbye, cow. Goodbye, items that the cow has dropped. We need to clean up the world. All right, so it still may not be completely clear where we're going with this, but let me say summon an armor stand in order to get an armor stand right here. And then let me run that same execute command, but I'm going to set block wool above the armor stand. And now we're going to run another command that we have seen before on the armor stand, which is the teleport command /TP. And so I could say teleport the armor stand by saying @e, an entity whose type equals armor stand, ~1 ~tilde. And that's going to teleport the armor stand one space over in that direction. And then I can run the same execute command again and get another piece of wool. And then I could teleport the armor stand once more, and I could run the same command again and get another piece of wool. And you may recall that there are 3 different kinds of command blocks, and one of them is a purple block that can run commands over and over again in a loop. And now you start seeing how if I were to run 10 iterations of a loop, I could end up placing a bit of wool 10 blocks away from me by summoning an armor stand here, running a loop 10 times. I've got n equals 10 over in my objective, over in the scoreboard sidebar, and then placing a piece of wool at the end. That gives you a sense of how we're going to do things. So now let's go actually take a look at a full example. So based on what we just learned, now we can make a set of commands that will place n blocks of wool in a row where n is some value that's already been computed in the scoreboard. So currently n has a value of 10, and I've got some command blocks right here. Over on the left is kind of just the basic initialization, where I am going to once kill any armor stands that are in the world, in case I have any left over from the previous run, and then summon an armor stand 5 blocks over from here, and so somewhere right around here I'm going to summon my original armor stand, and this is hooked up to an impulse block, so if I power this thing, this will just run once. And then I have a purple repeat block over here, and so this stuff will run in a loop. And these chain of commands are going to do what? They're going to scoreboard player test and my objective 1 star. Test if a scoreboard objective has a value between some minimum and some maximum value. I don't remember in the previous episode if we talked about it, but you can use star as kind of a wild card, don't care. So in this case, scoreboard player test n my objective 1 star means test if n has a value of at least 1, but it doesn't have any kind of at most ceiling. So it's just going to test if n is at least 1. And then you'll notice the shape of the arrows on these blocks over here mean that these are conditional blocks. And so conditionally, if this thing is true, then we are going to execute at the location of the armor stand, set block ~3 wool. So we're going to put some wool above the armor stand. Then we're going to teleport the armor stand 1 block over in the x direction. And then we're going to say scoreboard players remove n my objective 1. We're going to remove 1 from n. We're going to subtract 1, so n will go down to 9, and we'll repeat the loop. And once again, test if it's at least 1, and do this whole thing. And so each time we'll be placing a block of wool, teleporting the armor stand 1 over, subtracting 1 from n, and as a result, this loop is going to run 10 times before this test finally becomes false, and these commands quit executing. So let's go ahead and show that off actually happening in practice. I'm going to run the impulse command, which is going to kill all of the entities in the world, all of the armor stands, because it says kill @e type equals armor stand. It's going to kill all of them, including the magic armor stands that I had that were showing off the commands in these blocks. But then we summoned a new armor stand right over here. And now if I power this thing in a loop, zing! Our armor stand very quickly, 20 times a second, will place wool above its head and then teleport 1 over to the right, and place wool above its head, teleport 1 to the right. And if you were watching the scoreboard over on the right-hand side, n had a value that went 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and now is down to 0 and stopped. And so as a result, we placed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of wool. And so we managed to take a value computed in the scoreboard and place that many blocks into the world by teleporting entities around and executing commands at their location. So again, to sum up what we just did, we had a value in the scoreboard, n, and if I wanted to place a block, say, n blocks away, there's no way to directly say that in Minecraft, but I can summon an armor stand in my location, and then in a loop, teleport the armor stand 1 block away n times, and then place a block over there, and that's a way to accomplish my goal. If you're someone who's done programming and isn't very familiar with Minecraft, that may seem kind of like a little bit of a weird and roundabout way to do things, and it is. But Minecraft command blocks were originally just designed to do little things in Minecraft, and eventually they've kind of grown into a more general-purpose computing framework, but there are still some general-purpose computing things that are not easy to do in any normal way with command blocks, but we can take advantage of these various Minecraft things in order to get a job done, and in order to work with an array of blocks, teleporting armor stands is one great way to do it. Now, you may have seen one of my recent videos where I drew a very beautiful, colorful picture of a fractal known as the Mandelbrot set, actually a couple of them. And if you haven't seen that video, I would recommend going and checking it out because I talk about just kind of an overview of command blocks and show off some pretty pictures. It's really cool. But in any case, we kind of learned all of the things that we need to do in order to program something like that. Maybe not quite everything, but just about. But rather than try to program something that complicated, let's try to do something simpler. What if I asked you at this point how we could draw a checkerboard pattern that kind of looks like this? I'm just going to place a few blocks down just so you get the idea. But basically trying to make a checkerboard pattern kind of like this, using command blocks. Based on what I just showed you with a loop of how to place white wool, you may already begin to come up with ideas of how to make a checkerboard pattern where it's going to alternate white and black wool and not just place it in 1 dimension, but actually place it in 2 dimensions. So think about that for just a moment. Well, when we just wanted to make a line of wool, we just had kind of one numeric variable, n, that was counting down for how many pieces of wool we wanted to do. I'm going to go ahead and say scoreboard players reset n to go ahead and remove it from the scoreboard. But you can imagine for the checkerboard pattern, we have things going in this direction and this direction, which I might call x and z, which correspond to kind of coordinates in the world. And we might have 2 numbers going around, and so I've already got some things set up over here. Once again, I have some initialization and a chain that comes out of an impulse block that will run once, and then a loop of other commands that we will see in just a moment. But the initialization is going to be kill any existing armor stands in the world, summon a new fresh armor stand, and then we will set 2 variables, x and z, in my objective, and both start them out as 1. We're also going to set a constant called 2 to the value 2, TWO, to the number 2. And we are going to place our first piece of wool. We're going to execute at the armor stand, set block 3 blocks above its head, wool, in order to get things started. And then if I go ahead and do some magic on my armor stands that are magically encoding all of the various commands that are inside these command blocks just to make them more visible so that we can see them as we're going through this. I'm just going to switch out the yellow ones and the white ones. So now here is going to be the body of our loop, and it's actually a little bit long. But basically we've got 2 things. We've got X and we've got Z. And I want to have the strategy of going across, where I try to go white, black, white, black, white, black, white, black, across until X gets... I want to do 8 across, and so I want to have X go from 1 to 8. When it becomes 9, then I want to kind of like back up and go down to the next row and start having it going black, white, black, white, black, white, black, white. And then when it gets to the end of that row, I'm going to go move down to the next row and kind of start going again. So that's what we're going to try to do. So we're going to test if x is already up to a value of 9. Test if x's value in my objective is between 9 and infinity, basically, if x is at least 9. And if it is, then we've gotten to the end of the row. Then I'm going to set x back to 1. I'm going to add 1 to z, because basically my x is going to be measuring how far across we've gone, and my z is going to be measuring how far down we have gone. And then I'm going to teleport the armor stand, -8 in the x and 1 in the z. You'll notice that these 3 blocks are all conditional blocks based on the value of this test. So if x is greater than 9, we're going to set x back to 1, we're going to move z up by 1, and we're going to teleport the armor stand back to the left 8 spaces and down 1 into the next row. Else, something we haven't seen before. We figured out how to do if-then back when we were originally doing command blocks, and we talked about conditional command blocks, and if a condition succeeds, then we will run some conditional command blocks after it. We didn't find a way to do if-then-else. If it doesn't succeed, then let's do something different. And a general idiom that kind of always works for that is what I have here. Test for block, tilde, 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 -4, chain command block, -1, success count 0. What this is doing is basically testing to see if the block at tilde, 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 -4, in this case, that's 4 blocks back in this direction, which is this other test that was testing if x was at least 9. I'm going to test if that previous test was a chain command block whose success count is 0. Success count of 0 means the command failed. A non-zero value means it succeeded. And so basically, that's a way to do a test that says, if that if test failed, then this test will succeed, and so we can do some other things. And so as a result, this is kind of like, if this command succeeds, then do these. Else, test if that original test failed, then do these. So that's just a general way to say else. Test for an old chain command block with a success count of 0. So if x was not at least 9, then we're simply going to add 1 to x. We're going to teleport the armor stand 1 over in the x direction. And as a result now, we've already done the computations that are going to move the armor stand 1 by 1 to the right until it reaches the end, and then move it down to the next row and start over again until it reaches the end. But now, after we've moved the armor stand to a new position, we actually need to put some wool in it, and we want to decide if we want to do white wool or black wool by just alternating. And one way that we can compute that, based on the values of x and z, is to add x and z together and figure out if it's even or odd. And so that's what I'm doing here. Scoreboard player operations sum of my objective is equal to x of my objective. So we take the value of x and we store it in sum. Then scoreboard player's options sum my objective plus equals z of my objective. We then add z to it. So sum originally had the value of x, now it has the value of x plus z. Then scoreboard player's operations sum percent equals 2. And you'll recall that percent equals is the modulus or remainder operation. So when we divide it by 2, what's the remainder? The remainder when you divide a number by 2 is either going to be 0 or 1. And so we'll test if it's 0. And if it is, we'll set block wool. When I don't have a number after the wool, it defaults to wool 0, which is the code for white wool. Then I'm going to do another else here, which basically goes and says test for block tilde, tilde, tilde -2, the block that's 2 back. This test against 0, if that was not true, if its success count was 0, then instead I'm going to set block wool 15. And wool 15 is the code for black wool. And so once again, basically, we're going to figure out where to teleport next, either just 1 block to the right, or if we reach the end of the line, then down a row and back over to the left. And then based on the values of x and z, we're going to alternate between white wool and black wool. So let's actually try this thing out and see how it goes. I'm going to run this thing, which goes ahead and kills all the armor stands with my commands, places the armor stand down over here and places our first piece of white wool. And now we're going to activate this loop and watch what happens. Ta-da! We're creating a checkerboard. I'll go ahead and turn this thing back off. But basically, the armor stand would move 1 to the right and place a black wool, move 1 to the right and place a white wool. At any given time, the armor stand knows, relative to where we began this whole thing, what its x and z coordinates are. It currently says x equals 3 and z equals 11, which means we are sure enough 3 blocks to the right. And if we count over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 blocks down. And so it knows what coordinates it's at, and at any point in time, it's computing the sum of x and z and then taking the remainder when you divide by 2 and choosing what color wool to do. And so as a result, we just made a nice little checkerboard carpet, which is effectively doing some mathematical computations and plotting a little graph of x and z coordinates with different colors, which is pretty much what I was doing in the Mandelbrot fractal video that I had that was so cool. I'm in a different world over here now, and I'm going to start up another contraption that's kind of similar to one that we just made. But I had a comment in one of my previous videos that as I was teaching this, I should give homework assignments. And I haven't given any just because it was the case that we hadn't really learned to do enough of anything to kind of like make anything interesting just yet. But based on what we just learned, you can make some very small modifications to that final program that I just showed in order to draw things that are much more interesting. And so I have an example of that going right now. I'm actually going to, let me go ahead and say game rule command block output false, just so I quit getting all of the commands showing up in the chat, so the chat is not as cluttered right here, so you can actually see what's going on. But I'm drawing a very pretty picture over here, and it turns out that this is one that is very, very simple to do. I'm going to let it run for just a moment here. So I think enough of this has filled in at this point now that you can see that there's a rather intricate pattern that's being drawn here that's kind of beautiful in its own way. And for those of you who know different things in math, you may recognize this as something related to Pascal's triangle or Sierpinski's carpet. But basically, it all comes out of a very simple rule. On the previous thing that we saw in our learning world, we basically had the rule that we had x values and z values, and if the sum of those two things was even or odd, we will place black wool or white wool, and it ended up making a checkerboard. This time, the rule that is being used is also a very simple rule. I'm going to color a block white unless exactly one of the blocks that's either one up or one left from that block is a black block. And so, for example, this block is white because both this one and this one, up and left, are both black. But this block is black because this one is black, but this one is white. So exactly one of the up and left blocks is black. And for example, let me do it over here, the block that the redstone is on right here, this block is black because the one to the left of it is black, but the one above it is white. And so basically check the block above you, check the block to the left of you, and if exactly one of them is black, then you should also be black. Otherwise, you should be white. And just by applying that simple rule, we get this very intricate pattern that has lots of interesting mathematical properties that you might read about more on your own. But if you are in the mood to try to do some of your own Minecraft programming, then I suggest trying to build this yourself based on what you just learned in this episode. Good luck! As just a quick hint, since we didn't use test for block in this episode other than using it for if-then-else statements, here I've been placing my wools 4 blocks above my armor stands, and so I'm executing a test for block at an armor stand, or actually 4 blocks above an armor stand, and I'm testing for a block 1 in the negative z direction, and testing to see if it's wool 15, testing to see if there's a black block in that particular location, just in case that helps give you a hint on how to do the tests. So that's it for today. I promised by the end of episode 4 you'd be able to start making some interesting things, and I think based on what I just showed you, you should agree that you can start making some interesting things at this point. Basically, we know enough about how to write programs that manipulate variables and numbers inside the scoreboard, and then use those numbers to go out into the world and place blocks in interesting ways. And once you can do that, you can actually do a whole lot in Minecraft. There's obviously still tons to learn, but at this point, I think we're off and running, and so I wish you luck with whatever creations you might start making on your own, and look forward to future episodes where I try to teach you some more details about command block programming. So until then, I will say bye-bye. But wait, there's more! As always, I go to the section at the end of the video where I talk about lies and omissions that I told during the episode. I don't think I actually told any little white lies during this episode, but perhaps some of you will correct me in the comments, but I did definitely omit a whole lot. It is definitely the case that the target selectors, that kind of like @e notation that we learned a little bit about in order to say like @e type equals armor stand, target selectors are a whole huge subsystem of commands, and one of the most computationally powerful bits of commands that there are, and so there's a whole lot more to learn there. And then we also learn the execute command to execute relative to a particular entity or target that's been selected, and since target selectors can select more than one entity, the execute command command is actually a way that you can like run implicit loops and do all kinds of interesting things. And so execute and target selectors are actually super interesting and powerful just on their own. And so we only kind of scratch the surface of them. But for the most part, just scratching the surface is enough to do interesting things already. So I'm not sure that I'm going to go into a whole lot more depth on those commands necessarily anytime soon, but there is a whole lot more there, and I don't want to give the impression that we've kind of covered everything there is to know with target selectors and the execute command. But I think that's really it for me today. I think I've said all that I need to say, so I hope that you guys are having a great day, and I will see you again soon. Bye-bye!